Presume that there are two particles up in a certain way. They are now put far apart from each other, and you only know the state of only one of these particles. Is it possible to determine the state of the other particle? Well, the answer is yes. If two particles interact with each other, they become entangled. If two particles are entangled, meaning their quantum states are strongly correlated, then measurement of one of the particles automatically influences the other, no matter how far the particles are from each other. And this is what you call quantum entanglement. Let's put it into simpler terms. I have a spoon and fork, and I place them into two different containers. After that, I shuffle the containers. If I open a container and finds a spoon, then without opening the other container, I can instantly know that it contains the fork. This will remain true even if you put the containers light years away. But how do particles entangle? Let's say we need to produce a pair of photons. An entangled pair of photons can be created by spontaneous parametric down conversion. This involves firing a single photon through a nonlinear crystal to produce a pair of photons, which remain correlated even when separated by large distances. Particles have a property called spin. Before we measure it, it can be in any direction. To measure the spin, we need to specify the direction in which you wish to measure it. If the spin is determined horizontally, then it can be left or right. But if we do it vertically, then it can be up or down. Note that one of the key facets of quantum mechanics is that it is intrinsically probabilistic. We can't know, even in principle, the state before we measure it. Say we have two entangled particles, A and B, and they are a light year away from each other. Without knowing the states of either, we measure the state of A. If particle A's spin is left, then particle B's spin would be right. As they are entangled, the state of the other particle can be immediately known. But wait, here's an awesome thing. When the measurement is made in one part of the universe, quantum information can be sent to an entangled particle even in another part of the universe. One more thing, quantum entanglement is just around the corner. Clocks that synchronize our technological world, keeping things like stock markets, GPS systems, cryptography that deciphers uncrackable codes, the super powerful computers that have supercharged processing power. And that's the spooky thing by Albert Einstein.